Hello everyone, in this tutorial we are going to learn how to make a flow graph. And if you're unfamiliar with a flow graph, I'm going to go through the basics of everything, and there's also a lot of good CryEngine documentation and videos on how to explicitly use a flow graph, but it's not too hard. So this is our agenda today. We're going to go over what is a flow graph and how do you use one. All right, this is very easy. I'll go through it really quickly, and I'll show you how to put it down, how to use it, and how to make it communicate. They're also going to go over how CryEngine or Crytek made their own flow graphs. It's also in the source code of the engine. And then we're going to make our own, and I'm going to show you how to debug your flow graph. So let's get started. So following back from our last component video, this is right here, my component. There's something called GamePlugin.cpp, and that is what all of your games have. Now just give it a quick gander. It's really simple. It has an initialize and a process function, very similar to the component logic. So initialize is the very first thing it does. Let me go through it right now actually. So initialize this is some of our game code. Initialize literally is what happens prior or once the game is loaded. All right, it's not when you put a component down. In this case, it's when the game loads. We're going to do these specific things. And then on a system event is actually, look right here, system event game post initialized. So once the game is initialized, we need to do all of these things. And of course, schematics, I am not too familiar with schematics, so I'm not going to cover it anytime soon until I need to. And of course, in the game unloads. So you may have some, just quick reference, you may have this G environment, game framework, add network client listener. This is for online gameplay. If you don't have a server set up, this is probably going to crash your game a lot. Just go ahead and comment this out. This is not needed. All right, and CryEngine does have their own multiplayer system, but you know, it's better to make one. I may do a tutorial on that later, but otherwise, let's just get started. Windows debugger. So I'm going to start the game. Of course, always takes a moment. And disable asserts. Okay. Let's just X out of Flowgraph for now. And let's go ahead and go to our default level. So if you're unfamiliar with how to put a Flowgraph component down, just go to AI and then tag point, but it's not letting you right now. So we're going to go to new layer. I'm going to just call this default layer. Okay. And the blue is what selects the layer. So let's go to AI, tag point, put it down anywhere you'd like. Then I'm going to right click here. And then we're going to go create flow graph. Really easy. I'm going to just call this default flow graph. Easy, right? And this flow graph thing pops up. If this thing doesn't happen to pop up, just for instance, let's go to tools, flow graph. We have the same thing here. And then we're under entities, default, tag point 1. So just double click on it. So what flow graph is, think of it as a visual scripting process for game logic. That is all Flowgraph is. And to use it, if you want to use something, we could go like to AI here, has all of these actions. Or if we want, we could go to camera, get transform, position, direction, rotation, and just press the delete button. Or we can maybe even just go to entity, go to that attachment. So for bones, it looks like. Or damage. So some of these are custom game mechanics. From what I understand, this is like copy and paste of Crysis 2. Still very relevant. Or the position of our entity. So if you just need something, the logical thing to do is what is it under? So if we need to go to image, or if I think I need something under logic, like this is logic gates. All right. And if you have any questions on what this is, there's a description right here for them all. Okay? Very simple. So we can get it lower. No, I guess not. That's all right. But that's just how you use Flowgraph. So let's just do a quick example. Let's go ahead and add an easy thing. Let's go put another empty entity down. Right here, go to components, mesh, and then we're going to give it a rigid body. right? And then I'm going to press 1 on the keyboard, or you could also just go up here, go up, and then let's just see if it has physics. So if you don't see this right here, right click, and then go to physics. And oh look, it drops. That's good. So now let's go to debug. And then we have this thing, input key. Put it down. So we need to know if it's enabled or disabled. Okay? So let's just do this. To game start. Just go to add node. Well, you right click, add node. You could go to game. It's a little difficult to do it this way. I prefer doing it like this. It's just a lot easier for me. And then when the game starts, it's going to put an output. I want to enable this. It's already enabled by default. Okay, so what key do I want? I want the space. Okay, so then when it's pressed, when I press on it, it'll do something, or when it's released, I'll do something. Let's do when it's pressed. So whenever it's pressed, so if I leave it held down the whole time, it'll keep firing. So I'll do both, just for example. And then we need to get the entity. See if we can just click on it, add selected entity, doesn't work like that. Okay, so let's do impulse, action impulse. Right, so we choose our entity, click on it, right click, assign selected entity. And then let's do activate every time this gives something. And we'll go over what all of these things mean. All right, and we want the impulse X, Y, and Z. We want it on the Z axis. So let's do 10. Okay, now let's control save that, control S, click on this, control G, space. Oh, look at that. So as long as I keep pressing it, it'll keep moving around. So let's go ahead and give it some more impulse. I want it to be obvious. Let's do 200. It's probably going to be too much. That's all right. Oh, look at that. It's gone. That's cool. So let's give it a little bit more mass. Let's go like 100. Right. See that? Physics, if there's more mass in an object, you're going to need more impulse or force to move it. Right? So this is that's how you use a flow graph. All right, it's very, very simple. All right, so let's go over what these things mean. So if we hover over this blue here, it's a Boolean. Boolean's true and false. So if we wanted to change this, we could either double click on it, uncheck this, check means true, 1, and then unchecked means false, 0. 0 and 1. Any is green. So it does not discriminate based on what you give it. So if there is some sort of input anywhere, it will enable it or disable it. It really depends. Okay? This is a string, and this is another Boolean. Okay? Any. Okay, so let's just go through the logic here. So it works like a circuit, if you're familiar with that. So let's just go ahead and press this debug button here. We could see everything going on with the flow graph. And we could just drag it and put it here. And scroll down and press the middle mouse button to move it around like this. So, and then let's just go ahead and run it. So you see, and I press this little ampersand on the far left of my keyboard. Not ampersand, it's a little weird. Let me show you what symbol it is. It is whatever this is at the top left of your keyboard. So just press that, and then you could see the logic here, right? So whenever the game started, it says 1 out of 1 fired. Okay, so you could see the yellow line going to the enable, and then you could see what happened here. And if you need to restart that, just press the erase, and then press the weird key again, and then just press Control G. There you go. See, 2 out of 1. All right. So now, how do we know when this is fired? So let's go back into the editor and press space. Look at that. So we know, and it keeps saying out of 4, out of 6, out of 11, so a lot. Okay, so that's how you debug the flow graph to see if it is working or not. We'll come back to this. This is very simple. Excuse my phone. Let me put that on mute for you. There we go. All right, so this is really, really easy. So this is how you use Flowgraph. If something is activated, it'll give you a specified type, and you can use that type however you'd like. Okay? So it's just visual scripting. It's like Scratch, if you remember Scratch back in like maybe 2014, or it's like water. Water flows, all right? And in this case, it is enabled, all right? Well, not right now. It is enabled. Stop it. It's disabled. Okay, so water is flowing. So when it stops, it gives alpha, stop it, okay? Very easy. So water flows, and in this case, water is allowed to go forward because it says enabled. And then when you press it, it's like opening a gate. Water is allowed to flow to the next portion, which is the activate. So one important thing I'd like to add here, if you would want to do everything visual scripted or through visual scripting, we use things called gates. This is the equivalent of an if statement. So this can be a little weird, all right? So this is the input, all right? So whatever is put into here, so if I give it a Boolean string, the letter F, what's going to come out is the letter F. And because it is a gate, think of this as a gate, not an if statement. It's like an if statement, but it's its own thing. So input is this Boolean. So is this gate closed? All right. Is the gate closed? It is not closed right now. So we're allowing things to go through. It's Control G, see? But if we close the gate for whatever reason, we're not going to allow things to come through anymore. This is just like an if statement. It's just a little bit different. See, now, that's not right. Oh, because this is disabled by default. So let's go ahead and do this. See, nothing's flowing out because we closed it. So if we open it, now it's not allowing it to do anything. So see, you can't think of it like it's an if statement. It's a little bit different. See, as I made that mistake right now, as you can see. So now, what if we don't know, right? So by default, this gate is closed. But if we want, you can just click on it, Control C and Control V, and then remove this. What if I press the letter A, right? And let's just do something called bool. And whenever it's pressed, whenever the letter A is pressed on the keyboard, this is going to give out true. Okay? But by default, let's just go and consult that. By default, this gate is open. But whenever I press the letter A, it should open. Well, works. Not bad. So, look at that. Pretty interesting, right? So let's change the logic up just a tad bit. All right, so it's only getting one output from game. And if we always go in, right, it's only going to have one output. So look, so it enables it once, but I'm already disabling it. So there's no need for this anymore. Not quite. You can make your own logic gate. Okay, so now let's do this. Let's add Control C and Control V. But now I want it to be key B. All right. This is a weird way to do it, but this is appropriate. So instead, A will just enable it, B will disable it. All right. Control A or Control G. Well, it's A, so it's firing, and then B. And we don't even need this anymore. All right, so Control, this is A, B. Let's click out of that. A, B. So let's go ahead and do this so you can see the logic here. Let's move it a little bit closer together just for sanity's sake. All right. Control G, A, it's enabling it. And I press B, now I can't do it. A, B, yeah. So as you can see, sometimes gates aren't entirely necessary, but sometimes you will be using them because they are the equivalent of an if statement. And you did see me use it in the previous example, but in this example, it didn't quite work. So visual scripting isn't quite like C++. It has its own logic to things. But It gets easier as it goes on, I promise. And some people even prefer that. So in order to save this, just Control S and then File, save all external graphs. Sometimes it's a little buggy here, but you'll be all right. So let's go back to the agenda. So we have, what is a flow graph? How do you use one? And now we need to look at CryEngine examples of flow graph in source code. So I'm going to assume you already built out your GitHub engine from Crytek, which is just CryEngine. So you've already built it out, and now you want to look at it. So let's go to CryEngine underscore win64, and this is your root, solution cmake win64, and then CryEngine win.64.sln, which is solution. Visual Studio. So we're going to go into that. And while we're doing that, let's just go ahead and go, well, let me bring it over actually. Well, IntelliSense is giving me some issues today. Good old Visual Studio. So let's go ahead and just kill it right here. All right, so this is our game project solution. This is our Crytek solution, CryEngine. And how do we know? Because I did not do all this myself. So we're going to go to Crytek's Flowgraph system, okay? Which is just right here. CryFlowgraph, flow system, and then we'll go to nodes. This is everything, guys. Look at this, start node, okay? This is all of CryEngine's logic. So if you wanted to see how they, see this is the game, the start game node. So if you wanted to see how they did everything for themselves, this is it right here, okay? This is it. You have everything here. So this is a good thing to take off in the, or to use for a boilerplate code or an example. Or let's look at Flow VR node, something I'm awfully familiar with, okay? So this is very similar to a component, okay? Let's go start with the first one. So we define our class here, and we have our memory usage, we have our Git configuration, and process event. I don't see initialize here, which is probably they substituted it for this constructor, but it's you know, to each their own. There's no wrong way in doing it, just got to make sure it works. So that's how you access Crytek's and CryEngine's flow graphs. Now, what is modules? So this is interesting. Look at that, it's more. All right, so this is really cool. All right, so now we need to make our own. So if you ever want to see how I did it, everything's right here. Everything you need. So let's make our own. And of course, this is the code. Zoom out a little bit. I'll give you guys a second to look at that. So this is the code we are going to be working with today. All right, so this is the Flowgraph example. I've tested it out. It works really well. And if it doesn't, we'll find out in a moment because debugging is a part of the process, guys. Nothing to be ashamed of. Nothing compiles the first time. So let's get into it. Now we are at the part of how do I make one? So let's go back to our game solution. We don't need CryEngine solution anymore, so we can X out of it. Just go back to our game solution. Let's get rid of that one. I had two open for some reason. Okay, so we're back on gameplugin.cpp. All right, this is where I put my flow nodes for our simulation. And this is it, right? Example flow graph, okay? So I got a complaint earlier that I was copying and pasting my own code. And I said, Alex, that's not fair. Well, I think it's fair, but I respect all developers. So I will do it again. Okay. So let's put this to the side. I'll put this to the side for you. And then we could do it all ourselves. So the first thing you need to do is make the class. Okay, so in this case, it's going to be example flow graph. And then it's going to extend the flow graph base. Okay, so C flow base node. And then ENCT singleton. Don't ask me what that is. I'm not familiar. Okay, so we have our class now. So we need to have our public functions. And then our, I guess you could say constructor. It is a constructor 100%. Example, flow graph. S activation info. This is a pointer. Then P act info. This is going to be an empty constructor. Okay, then we need to have our virtual functions, which we'll go over in a moment. Virtual void get configuration, then flow config and config. Okay. All right, so what's next? I'll just go ahead and do all of the virtual voids. Virtual void process event, flow event, evt, activation info, act info. Okay, there we go. And then one more. Virtual void get memory usage. cry sizer pointer s. That's a constant. Okay, and do this. Add this. And of course, you need that. Not that, but you need this. And this. Yeah, good. All right, so guys, so we have everything we need. So Git configuration is setting up the Flowgraph's input and output. So remember we had our input, we put something in, and then it activated an output. So we have to do all of that ourselves. So it's static const s input port, just port config, yeah. Control space for code hints, in config array equals. So there are multiple types. There's I'm just gonna go over a few. There's input port config void, which is that green, the any, get, and then you have a comma, underscore, help, which is just a description, activates Flowgraph. Input port config, let's do type bool. This is our boolean. This is our boolean input, and I'm just going to call it toggle. And then help. We're going to call this bool input. Same thing we have in the code I have on the side of the screen. And then comma input port config int. And then integer 1. Just call it that. And then help int input. So very rudimentary. And this does not have a semicolon here. It is a comma. Very important. Okay, and don't forget your semicolon here. Okay. So now we need to do our output port. So static constant s input, or s output actually, output port config out config equals. All right, same thing here. So we have output port. Let's do void. So this is just activated. All right, and we have help, or these are all caps, help, and then activation output as comma output port config is bool, and then let's just call it less than and comma. Okay, and we need our semicolon. So we're almost done setting it up. So we have our inputs and then we have our outputs. Now we need to actually kind of register them. Config.s description. So we need to give the Flowgraph a description. Help. This is my example Flowgraph. It will show if it's less than 10, which is this is the goal of this Flowgraph. Config dot s input input. So yeah, p input ports equals in config dot p output ports equals out config. Okay, so you see how it works out. We're literally telling it this is our input and this is our output. And then we need one more category. Config.set category. As by default, EFLN approved. I'm not too sure what this is, but let's go into it and see what it is. This node is approved for designers. That's all it is. So these are just flags. You can go through this in detail on your own time, but this is what we're going to use. Let's use the approved one, okay? So we have everything we need. We've set up our flow graph, all right? We've initialized it in a way. So now we need to go to process event. This is very similar to the component that we built. So we will have a switch statement, EVT. And you could do if statement too if that's what you'd like, but for this we'll be using if switch statements, just keeping precedence with what I've already written. So case EFE activate. Okay, now what does this mean, guys? Let's go to break here. All right, just so it won't complain too much. Let's go into this. Sent if one or more input ports have been activated. So anytime an input is given to a port, this event will fire. And there are other ones too, but this is the most basic one to use. Okay? You can also use update. I assume it changes when there is an update, but there is no documentation here, so that will be trial and error. But we're going to use this one. One or more ports inputs have been activated. Okay? So let's go here. So now we need to get the data from our flow graph. Let's do 0. So I'm putting zeros here because it starts counting at 0. So this is spot 0, 1, and 2, just like an array. All right. So we keep that precedence when we're accessing information. So if is port active, okay, and parameters p act info, and then 0. I put a comma here on accident. All right. So, and of course we need to. So this is just wanted to check if it is active. So has this first port been activated? Is it just getting any input? And I mean anything. And if so, we're going to continue. All right. And of course, this returns a Boolean as needed per if statements. So, and then we're just going to go ahead and activate output p act info, and then 0 true. Okay. So we're activating this very first output node, and we're sending off the value true. So just as the any node can, or any input, I should say, can receive any type, we can also send off any type. In this case, I'll just be sending off true because that's not a lot of memory. It's just one bit, 0 or 1. In this case, I think they use 64 bits. I'm not too sure. Don't quote me, but this is, I don't want to send a lot of data if I don't need to. So we're just going to activate it. So once we have an input, immediately we're going to have an output. Now, it's just nonsense that we're sending off, but this is just for example cases. And we'll get to the logic in a moment. Now, we want to go further. If get port bool, see that? You can get port bool, port int, port float maybe? Yeah, port float. What about double? No double, just float. So get port bool in this case, p act info. We want to get position 1, and then that's really it, yeah. And of course, we need our brackets. So if get port bool is true, so if this input right here, 1, I'll go and put 2 here. If this input is true, go ahead and proceed with what we're going to do. So what we're going to do is now we're going to compare. If 10 is greater than get port int p act info 2. I'm just going to go ahead and activate the Boolean here. So activate output p act info 1 true. Okay, very, very, very simple. Okay, so let's go through our logic. So if we have any port that is activated, if any port has been activated or has new information or it's just receiving input, we're going to go ahead and go through this case here. So let's comment this. If port 0 input is active, receiving data, right? Go ahead, output data at port 0, which is the right side. Okay, so that's by default. Now, is port input is input at port 1 true? We're going to proceed. If input is input at port 2 greater or less than 10, then we're going to proceed. Output a Boolean. Okay, so very straightforward logic. If we have an input, if we're true and we have a number that is less than 10, remember guys, if you're a little confused with this, the alligator mouth eats the bigger number. 10 is greater than whatever number this is going to be. Okay, so we need this number to be less than 10 for it to fire. Okay, all right, so we're almost done. We need to do one more thing. Okay, so in order to register our flow graph, this has to be present. Okay, so it's just like the component. So we have our folder. So let's do my custom flow graph, my custom flow graphs, and then we need to give it a name. Even though we called it example flow graph here, ex flow graph, it does not translate. That's just a class name. So we're going to call it example flow graph. And then we're going to copy this, paste it here. Okay. So, and then Control Shift B. So it's going to compile. Look at that. So all good, no failures. Now we're going to start the simulation or start the game. We make simulations here. So I always say simulations and not video games. All right, disable asserts. All right, guys. So let's just go ahead and no do rendering. I don't want any crashes right now. Let's go to recent files, my level. All right, loaded up really nice and fast. So let's go to entities. Let's just pull this out here. Let's go to tag point. All right, so this is our logic. We don't really, we'll keep it here just cause. So how do we find our flow graph? You can just search it. Flow graph. Look at that. My custom flow graphs. A little long. There we go. And then here's our flow graph. Yay! Look at this. There we go. So let's test it. So let's add game start. Whenever the game starts, we're going to activate it. And we're going to do this as well, toggle it. And let's just go ahead and give it a default integer of 4. All right. And activated. So what do we want to happen when it's activated? Let's see about giving it a little impulse, right? So I don't want to block off 1, so I'm going to do something called a mux or multiplexer. Do they call it that here? Yeah, multiplexer. So what a multiplexer does, whenever there is input from 1, no matter what, if there's an input from here and from here, there will be an output here. So if none of them are firing, this will not fire. If only one of them is firing, then this will fire no matter what. So always mode. So I can't quite see it. So let's see if we can zoom in on it. So that, look at that, ports only. Yeah, so both the index and port trigger output, guys. It's really, really simple. Okay. 0 to 7. Okay, cool. So for proof, let's go ahead and do this debugger here. And let's move things a little closer in. All right. And of course, let's do this as well, just for sanity's sake. Let's put it, so right now nothing should be toggled, so let's put it down here. And if it's a little small, just drag it up and zoom out, control, and you can scoot your scroll wheel, so control G. Look at that, so it already fired, which means it's working. So it fired and it gave us a true because the game just started, which it activated the input here, and then it activated the toggle here because it's true. And our determining factor here, and remember, only activated it once. It only activated once, guys, because the game only started once, it only fired once. So we have our integer as well, which is less than 10. But if we say we have 11, this is not going to fire. Let's go ahead and just control G that and X out, or press the escape button, and then run it again. Okay, look, it technically did fire, but the less than did not fire. So remember, whenever we have an input, no matter what, there will be an output. But it is also toggled, but it does not meet our requirement of being less than 10. So if we go back into the code here, remember, if there is an input, there will be 100% an output no matter what. But if our Boolean right here is not true, but in this case it is true, but let's just say it wasn't true in this case. Let's just take this off, kill that, and say this is 0, which is false. Okay, which means this if statement will never be touched. It will never be hit. And the way to check that is just, you can use a debugger here too. It doesn't hurt. It's the same stuff. But it was not toggled, which means it's not hitting it. But if we do hit it, if we want to hit it, toggle. And now we're going to check this if statement. So let's just put a debugger here, just for sanity's sake. I haven't tested this out. I've done it in the past. All right, just run it here. Look, a debugger hit it. So now we know this is working. So it's checking, is our integer less than 10, or in actual terms, is 10 greater than our input integer, right? Then we're going to fire out the Boolean. So let's do that too. Let's put this here. If we continue, it's not going to touch it. See? So let's go back here. But let's go ahead and make this 9. Okay? And it's by default, we have toggled it. Okay. So look at that. So I press Control G. The moment I press Control G, it fires. It's really fast. And then press Continue. Look at that. Because our input is less than 10, or 10 is greater than our input, we are activating the true output, which will make it impulse twice. Okay. See, it kind of bounced twice. So let's take off these debuggers and just watch it do its magic. See? Or maybe it only fired once. Looks like well, it looks like it's firing twice. Hard to say. But we are getting 2 inputs. So we're getting port 1 here, and then port 6. If we want port 0, just press space. See? Okay, guys. Congratulations, you now know how to make a flow graph in CryEngine. In the next video, I think I may cover a little bit more on the logic side of Flowgraphs, because I just realized the only reason I know these logic gates and things that are similar is because I have circuit knowledge, and circuit components like electricity, they use these exact same things. So until next time, thank you for watching.